Now that we've talked about sequences, let's talk about series. A series is the sum of a sequence. Okay, so series can be written in a special notation, and this is called summation notation. Okay, so sometimes you might see it written like this, and I'm really bad about how to make these. This is the Greek letter sigma, capital, and like I said, I get really lazy at the end when I'm making them, and excuse my phone going off there, but ultimately this is the capital letter sigma, and on the bottom we're going to put the first, so k equals 1. K is going to be the variable used in the explicit formula for the sequence, and the top number on the top there we're going to put a 5, and that's going to be how many terms that we're going to add. We're going to start with k equals 1 and we're going to stop with k equals 5. And then the explicit formula for the sequence would be written here, and that's going to be 2k. That's just an example that I'm using. Okay, so this would be considered summation notation. Another way to write it would be just like 2 plus 4 plus 6 plus 8 plus 10. This would be the first term, second term, first term, second term, third term, fourth term, fifth term. And that's the other way we can see them written. Now you just finished a unit on arithmetic and geometric sequences, so we're going to stick with that. Arithmetic sequences can be added. You can do partial sums or sums of so many terms by using a formula. Okay, so the formula that we're going to use, they would call it the sum of n terms, and that sub number n there is going to equal n, that's the number of terms, times a1, which would be your first term, plus a sub n, whatever that number is, the last term in the series that you're going to add, and we're going to divide that by 2. Okay, so n equals the number of terms. A1 again is your first term. An is the last term in the series. And that's what you need to know for adding an arithmetic series. So again, this is for arithmetic. Let me add that in there. And that formula you're going to want to have around and handy. So here's what we're going to do. We are going to find the sum of the arithmetic series. Example number 1, I'm going to say we want to know S15, so the sum of the first 15 terms for a series 25 plus 12 plus negative 1 plus negative 14 ... Okay, so I'm not giving you all 15 terms, I'm just giving you a few. So ultimately, what we need to find here is we need to find the first term. Oh, that's right here. This is our first term. We need to find the number of terms. This is our number of terms. And we need to find the last term. So we need to find A15. So in order to find the 15th term, we kind of need to have the explicit formula. So to write the explicit formula, we need to know the common difference. So the common difference is found by taking the second term and subtracting the first term. Oh, that's negative 13. Okay, so A2 minus A1, that's how we find the common difference. So the explicit formula would be A sub n equals, we're always going to start with the first term, so it's A1, and then plus n minus 1 times d. Well, our common difference is negative 13 in this case. So that right there is our explicit formula. So for every arithmetic, this would be the formula that you have to use. For every arithmetic. And then for this one in particular. So we need to find the 15th term. So a sub 15 equals 25 plus 15 minus 1 times negative 13. Okay, do the math on that. We're going to get negative 157. Okay, use a calculator. That is fine. Now for the sum of the first 15 terms, that's going to equal 15 times the first term, which is 25, plus the last term, which is negative 157, all divided by 2. Okay, so we do the math on that. We're going to get 15 times negative 66, which is negative 990. That is the sum of the first 15 terms. Okay. So the next example I want to show you has, I'm going to give it to you in the sigma notation or summation notation. So example 2, we're going to have, I'm going to try to do this very carefully. Capital letter sigma. Ooh, it's so much nicer on here than it is in my actual notebook. We're going to add the first 12 terms. And the explicit formula is 3 plus 4k. Okay, so ultimately, here it is. When I give it to you this way, it's way easier than when I just list it out in the series as the sum. That's weird. So ultimately, we need the first term. So a sub 1, that's going to be 3 plus 4 times 1, which is 7. We need the 12th term, which is 3 plus 4 times 12, which is 51. And that's all we need, and we're ready to do that partial sum formula. So the sum of the first 12 terms in this series is going to be 12 times 7 plus 51 divided by 2, which is going to equal 12 times 29, also known as 348. So the sum of the first 12 terms equals 348.